Hello everyone, welcome to Chemizone Complete Chemistry. So in our today's video we are going to study interconversion of wedge dash projection formula to Newman projection formula and Newman projection formula back to wedge dash projection formula. So let us first see how do we do this conversion in a 2-carbon molecule, that is an ethane derivative. So if you look, this is the structure of the wedge dash formula, and if you look at this structure from this mouse perspective, you would find that this bromine which is coming out of the plane of the paper will be on the right. This is a Newman projection formula. So this is the front carbon. Here the front carbon is the carbon in brown. So this is the front carbon and bromine will come on the right, chlorine at the left, fluorine atom at the top. And if we look at the back atom, that is this purple atom, you can clearly see that bromine is at the bottom. So bromine will come here, chlorine at the right and fluorine at the left. So this is how you convert a wedge dash projection formula to a Newman projection formula. Now let us see how do we do this conversion in case of more than 2-carbon molecule. Now here you can see that there are 4 carbons, that is a butane molecule, a derivative of butane. So we can write this Newman projection formula across, let's say, carbon 1 and 2, that is this carbon-carbon bond. We can also write across carbon 2 and carbon 3, and also we can write among carbon 3 and carbon 4. So here let us try to understand how do we write for carbon 2 and carbon 3. So this carbon becomes our front carbon, that is this point. The third carbon becomes this back carbon, which is shown in this circle. So this front carbon, which is shown in red, you can see that if we look from this hence perspective, the chlorine would come at the right, fluorine at the left, and methyl group at the bottom. Similarly, if we look at this back carbon, you would again find that the methyl is at the top, iodine, which is coming out of the plane of the paper, but for this hen it would be at the right, and bromine at the left. So in this way, for a carbon chain, we can write down the Newman projection formula for whichever carbon-carbon bond we wish to write. Now let us see a little more complex conversion, that is of cyclohexane. So this is the cyclohexane molecule, as you can see here, and this structure is nothing but called as a chair conformation or chair conformer of cyclohexane, which we will be studying in our coming videos. What are the different conformations of chair of cyclohexane? So if we look at this cyclohexane molecule from this elephant's perspective, you would find again we can write down the Newman projection formula for this molecule as well. So if we look from this perspective, you would find that this carbon in brown is at the front, is the most nearest carbon to this elephant. So we write this carbon over here, as you can see here. Now this carbon in brown is attached to 2 other carbons, which is shown in red. So these 2 carbons shown in red are our front carbons, as you can see here, which we use to represent with a dot. But for better understanding, I have mentioned these carbon over here. So these are these 2 red carbons, as you can see here. And then these 2 blue carbons, the next 2 carbons which are attached to these red carbons are the back or rear carbon, which is shown in this blue circle, as you can see here. And then at last you would see this green carbon, that is this CH2 group, as you can see here. So these 2 red carbons are the carbons which will be hiding these 2 blue carbons. Okay, so and all the substituents you can see are hydrogen. So for the front carbons we have written 2 hydrogen substituents, and then everywhere there is hydrogen which I have filled. So this is how you can write down the chair projection formula into the Newman projection formula for the chair conformer of cyclohexane. Let us see once more. This is the front carbon, which you can see here, the CH2, then the two red carbons which are at the back. These two carbons, as you can see, are attached to two hydrogens each, which I have shown here. And then these two red carbons are attached to the blue carbon, which you can see here. And then they are also attached to hydrogens, as you can see here. And then finally, there is this last green carbon, which will be seen. So this is how we write down the Newman projection formula for cyclohexane. So here we come to the end of today's video. Thank you so much. In the coming more videos, we will see some more conform interconversions, and we will also see different conformers of cyclohexane, the stability of cyclohexane conformers, and also we will study in further videos some topics like topicity and diastereoselectivity and stereospecificity and many more topics. Please don't forget to like, share and subscribe to our channel for more such interesting content, and please click the bell icon to get the regular updates and notifications. Thank you so much.